Hello and welcome back to another edition of ACE Math Homework Walkthroughs. We are working on homework 7.1, so this is differentiation. And we're looking at the first problem on the homework, which is number 12. So we start with, we've got a curve. Okay, like that. And we've got points A and B. And the curve passes through those points. And it says at each of the points C and D on the curve, the tangent is parallel to AB. Find the equation of the perpendicular bisector of CD. So let's try to draw a picture. Okay, this is a 1 over x problem. So we're going to look something like that. Actually a negative one, so maybe something like that. Okay, A and B are there. For each of the points C and D on the curve, the tangent is parallel to AB. What that is saying is the derivative of the curve. Okay, so dy dx at C and D are equal and is same as line AB. So we need to find the equation of the perpendicular bisector of CD. So what do we need to find? So let's just see what this is. We need to find the gradient of AB, points C and D, midpoint of CD. So let's see what of this we can determine right now. So we could probably do the gradient of AB because we have the 2 points. So M of AB. So change in Y. So let's do 11 minus -1 over 4 minus 1. So the gradient of AB is 4. So that means the gradient of the perpendicular bisector of CD Nope, I actually don't need this. Actually, we did need that part. We just don't need the perpendicular yet. So we found our gradient of 4. Now we need to start thinking about where do we use that? Well, we have a curve, right? So we have y equal to 3x minus 4x to the -1 power. Okay, the tangent is parallel to AB. So it's where the slope is the same. So the slope of the tangent line is the derivative. So this is 3 So we're going to multiply by our exponent and then subtract. So this is 1. And we subtract 1, so it gives us x to the 0 power, so left with 3. So we're going to multiply by our n, so this is going to be plus 4x, and then negative 1 minus 1. So we get 3 plus 4x to the negative second power. That is equal to 4. So we can solve this, so we get 1 equals 4x to the negative second power. So we get 1 over 4 equals 1 over x squared. So I get 4 equals x squared. So x is plus or minus 2. So those are the points. So those are the points for C and D. So if I'll say this is C, and this is D, 2 and negative 2. So I just put it back into our equation and evaluate. So 3 times 2 minus 4 over 2 gives me 4. And then do the same thing. 3 times negative 2 minus 4 over negative 2. It's negative 2, negative 4. So there's points C and D. So now we need to find the midpoint and the gradient. Gradient negative 8 over negative 8 over negative 4, which gives you a positive 2 slope. And then midpoint is going to be going to be 0, 0. So the equation of the perpendicular bisector of CD is y equals 2x. So I said it was y equals 2x. So you go back and you read the problem. So you're looking for the perpendicular bisector of CD. Well, we got the bisector part. Oops. We got the bisector part, but we forgot to do the perpendicular part. So this should actually be y equals 1/2 x. So there we go. That's problem 12. So let's go on and look at problem number 15. So looking at 15, it's a 12-point problem. So this is about a third of the points you need to pass the exam in one problem. So it's going to call into our knowledge all of what we know about lines, equations, and differentiation. So let's break this down and see what we're given. So our given information. So we have a curve. 6x plus 2 to the 1/3 power. Okay, we've got point A, which is on the curve. The tangent to the curve A cuts the y-axis at B, and the normal to the curve at A cuts the x-axis at C. So you know what? I think the best way to cover this given information is going to be copying a bit of this sketch. So we've got our cubic function. So we have point A. So the tangent to the A. So this is that cuts B. So the normal to the curve at A so it makes that perpendicular because a normal and a tangent perpendicular to each other. That's C. Find an equation of the tangent AB and the normal AC. Find the distance BC let's focus on those two first, then we'll come back and look at our picture. So first things first, we need to find the equation of the tangent AB and the normal AC. So we need to find gradient of AB. Well, we do that by the derivative. So dx so dy dx of 6x plus 2 to the 1/3. So in order to do this, we're going to need the chain rule. Which is derivative of the outside times derivative of the inside. So the outside is that, and the inside is that. So derivative of the outside is 1/3 and derivative of the inside is 6. So we're going to have, our derivative is going to look something like this. 1/3 6x plus 2 to the negative 2/3 times 6. So there we go. That's our function. And now we need to evaluate it at A. So at x equals 1. So let's switch this up. So dy dx equal to the m of AB is equal to 2 6 times 1 plus 2 to the negative 2/3 power. So this is going to be 8 to the negative 2/3 power. So this is going to be 2 over, that takes care of our negative, 8 squared, the cubed root. So I could do this on a calculator, but I think it's more fun for you to see the math done out longhand. So we've got 2 divided by, now, 8 squared. So I'm going to have 8 times 8. So 8 is 2 cubed. So it's 2 cubed times 2 times 2 cubed. And I'm taking the cubed root of that. So I'm going to end up with 4, 2 over 4. So my m of AB is 1/2. So that being the case, then my m of AC is negative 2. So my equations are going to be y minus 2, 1/2, x minus 1, y minus 2, negative 2, x minus 1. So those are our two equations. So now that we've got our two equations, we can now work on part B, which is finding the distance BC. So looking at our picture, in order to find this distance, we need to know what the points B and C are. Well, it's going to be the y-intercept of line AB and the x-intercept of AC. So we need the y-intercept of AB, so that's where x is equal to 0. So we've got negative 1/2 y minus 2. So y is 3/2. So b is 0, 3/2. Our other one where y is equal to 0, and x is equal to 2. So c then is 2, 0. So our distance formula then, our distance is going to be the square root of change in x squared. So that's 2 squared plus change in y squared. 4 plus 9/4. It's going to be 16. So it's 25 over 4. And then the distance formula, 5/2 is the distance between B and C. Well, for the last part, it says find the coordinates of the point of intersection E of OA and BC and determine whether E is the midpoint of OA. So we have B, we have C. So what it wants us to do is write an equation for BC. So that's going to look like y minus 0 So y is negative 3/4 x minus 3/2. There we go. So x plus 3/2. So that makes sense. It fits our picture. So I have to find E. So E is where it crosses OA. So BC is and then OA this is y equal to 2x. And looking for where they cross, so the y will be the same. Multiply through by 4. You get x is equal to 6/11. So you get 6/11 for x. And since OA is 0, 0, and 1, 2, the midpoint is going to be 1/2, 2, and 6/11. 6/11 is not equal to 1/2. So there you go. There's problem 15. And I think that'll do it for this video. We'll call this part A. And look for the second video for part B for 9 and 6. Alrighty, we're picking back up with our AICE Homework 7.1 walkthrough. We've done page 209. Now we're on page 235, looking at number 4. So this is one saying that the watermelon is spherical in shape and it's growing. It has a mass m kilograms and a radius in r centimeters. And they're related by the formula kr cubed, or k as a constant. We also know that dr dt is 0.1 centimeters per second, which I'm going to write it as 1/10 to make it easier. Okay? And on the particular day, the radius is 10 centimeters, and the mass is 3.2 kilograms. So what it wants us to find is find K, and then also find the rate at which mass is increasing. Find dm dt. So let's work this out. So we want dm dt. We're given dr dt. So what we need to do is multiply by dm dr. So we ask ourselves, do we have an equation of m in terms of r? And we do right here. So now we're just going to plug stuff in. So 1 over 10 times the derivative of that function. So it's going to be 3kr squared. So 3kr squared over 10 is dm dt. So now all we have to do is figure out what k is. Well, this is not as tricky as it could be. So we go back and we look at what we've used. Well, we've used this, but we haven't used these two pieces of information yet. So if we say 3.2 has to equal k times 10 squared, we can simply solve for k and get that k is 0.0. Let's see, 10 squared is 100, so it's 2 decimal places, 2.032. And then this is density, so this is kilograms per meters cubed. Kilograms per meter squared. Oh, this is cubed. Sorry. Screwed. I knew it was density. So this is 0.0032 kilograms per meters cubed. There we go. So now we can simply put everything together. So 3 times 0.0032 times 10 squared all over 10. So this cancels out with that. That moves it over. So we have 0.096 dm dt. So we found dm dt, and we found k, which is what they were asking for. So that's that one, and then let's go on to the next question, and the last question in the homework. So this is problem 6. So this is 235, number 6. Now, this problem we've seen already. This was the quiz problem. And I like this one because there's so many different ways you can solve this. 1, 2, 3, 4. Oops, I gotta enclose one more square. All right, and they tell us this is y and this is x. So you have to do is you count the x's. 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12x plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10y. Okay, now that has to be equal to some other piece of given information they gave us. So that's the perimeter. So 480 meters. Now we also need to find area. Well, we know the area of each one of these squares is xy, and we know we have 8 of them. So the area is 8xy. So what we do is y is 48 minus 1.2x, right? I just solved for y. Now this can substitute in there. So it's 8x times 48 minus 1.2x. And then 48 times 8 is 384x minus 9.6x squared equals area. So that's the first problem. That's just a proof. Now the second part of this is given that they can vary, find the dimensions of the sheet pen which A is a maximum. Well, maximum occurs at stationary points. So dA dx equal to 0, so equals 384 minus 19.2x. And just solve for 0. So 19.2x equals 384. X then is equal to, let me grab a calculator. Equals 20. So we know 20 is the maximum. So that's x. We can plug 20 back into our 12xy equation. So we can do 12 times 20 plus 10y equals 480. So y is equal to 48 minus 24. So y is equal to 12. So there's our ordered pair. 20, 12 is our maximum x and y. But we have to prove that it's a maximum. So we take the second derivative. So we do d2a dx squared. And we end up with negative 19.2, which is less than 0. Thus, max. So there we go. And that's that problem. Now, that last part didn't have to do. Doing what we did here, looks like would have been sufficient for the problem. So hopefully this walkthrough helps you understand the problems a little bit more. For the second two, I went through a little faster than I normally do, but they're also a little more straightforward than the original two. So if you have any questions, as always, let me know. Otherwise, Mr. Bose, out.